Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Snexville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at lccc. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. Let's take a look at the gas laws as they're presented in the textbook of the course we have here at lccc of Chem 106. If you're taking a different chem course either here at lccc or other colleges, you may find that your textbooks presents some additional gas laws. These are not all of them, but these are the ones that pertain to our Chem 106 course here at lccc, and that's what I'll review today. You'll see here in the table on the left we have these 5 gas laws that are presented. And basically what's being introduced here is dealing with problems where you have a initial condition, one with some gas material, and you're going to a change condition number 2. And that change, maybe you're changing volume, maybe you're changing temperature, pressure, number of moles of gas, but you basically have an initial condition going to a secondary condition with a gas, and here's how you can predict the properties of that second condition. And so that's what these gas laws are good at doing. So if we look at the first one, which is Boyles Law, initial pressure and volume will be related to the second or final pressure and volume through this relationship, PV equals PV. One thing to remember here in red on the left, units must be consistent. So if you start with, let's say your gas, initially you had 1 atmosphere here when you started and your volume was 1 liter of gas, they'll change that to a second condition, but they need to be in the same units as the initial. So let's say that in your second condition your pressure increased to 2 atmospheres, and what you're looking for is your the resultant volume, V2, if you do that. So if you start with 1 atmosphere with 1 liter and now introduce a new pressure of P2, what happened to the volume of that container in order for that to happen. And so this volume V2 is going to be in liters because your initial volume was in liters. And you'll simply solve this equation. You should be able to realize if you divide both sides by 2 or 2 atmospheres, these cancel out. So you're going to have 1 times 1 divided by 2 is equal to your V2, and that's going to be just 0.5 liters as your resultant second volume. And that's how you go about introducing what you know and looking for the resultant unknown, in this case V2. Similarly, you do that with the other gas laws. They're just different things changing and different parameters that you're looking at. I'm going to do one a little more complicated with Charles' law next. The 3 equations here, Gay, Lusak's, Charles, and combined laws, you notice introduce temperature. And again here on red on the left, which remember temperature must be in degrees Kelvin and for these gas laws to apply. And so if we take an example, if we're going to use Charles's law, that's V1 over T1. It's going to result in V2 over T2. So you're given a problem. So what you're given here is your, say, volume 1 is 5.4 liters. You're given that your initial temperature is 15 degrees centigrade and your final temperature is 42 degrees centigrade. And what you're looking for is V2, what would be your resultant volume with those conditions. What you have to remember is you need to change your degrees centigrade to Kelvin. In this case, 15 degrees centigrade, you should be able to convert that to 288 degrees Kelvin, and your 42 is going to be 315 degrees Kelvin. So move over here to the left, we plug in our numbers. We have 5.4 liters over your initial temperature of 288 is going to equal to V2, which is what we're looking for, over 315 Kelvin for your resultant final temperature. And then you should be able to do this, the mathematics here. You'll find that your V2 is going to be equal to 5.91 liters. And so just remember that on 3 of these laws where temperature is involved, you do have to use degrees Kelvin. Now for the final law that's presented here is Avogadros Law, and that relates to changing the number of moles. Avogadros Law is V1 over N1 is V2 over N2. And let me start that. That's lousy writing. Okay. And I got to look over there. Avogadros Law, V1 over N1 equals V2 over N2. A common way to do this in a problem is this way. Say you're given that your initial volume, let's say in a balloon, is 1 liter. And what you have when you begin with is 2 moles of hydrogen. Then the problem would tell you that you're going to add 2 moles of helium into that balloon. And it asks you is what is the resultant change in volume. So the trick here, if you want to say, is determining the final number of moles, because they didn't give it to you, say, directly. You have to calculate it. You started with 2 moles of hydrogen, but in the second condition, so your N2, you still have your 2 moles of hydrogen, and you added to it 2 moles of helium. And so your N2 is actually 4 moles of a gas mixture. So when we go to solve this, move over here to the left, your V1 is 1 liter over your initial number of moles, which is 2 moles, and those are hydrogen. Your unknown is your resultant volume, and now your second volume, your final volume here, is 4 moles of a mixture of helium and hydrogen. And so to solve this, it should be fairly obvious. It's 1 over 2 equals V2 over 4, and you'll see that V2 is going to end up being 2 liters. So your resultant volume is 2 liters. So that's a common way that they'll introduce Avogadro's gas law into a problem. Now let's, as a final note, if you need to memorize, as you will probably need to do for this course, these different laws, there's a little bit of a trick that might help you. If you remember Boyles Law of P1 V1 over is equal to P2 V2, the next 3 laws here are related to that first law by introducing temperature into the equation. So a way to look at it, I'll do the first one. You take P1, you take your first term, put it T, and that's, you'll see the Gay-Lussac's law over P2. Now you can take the second term, V1 over T1 equal to V2 over T2. And that gets you your Charles law. And then finally, if you take the entire term, PV, and put it over T, you have your combined gas law over T2. So from this initial equation here, if you remember that, just remember there's 3 more equations you can get from it by just introducing T under each term, pressure and then volume, and then over the combined term of PV. So that is I think, a way to try to remember those three laws. And then you're still left with having to remember Avogadros Law of the V1 over N1 equals V2 over N2. I hope that's helpful for you. Thank you.